We are back again with another assertion reason session for class 12 chemistry, and today we are going to discuss the second session on D block and F block elements. I am here, Manisha Sharma, for 1 mark solution, and the video link is right in front of you. The first statement for assertion is sodium dichromate cannot be used as a primary standard in titrations. This is true. Sodium dichromate is Na2Cr2O7. And we do not use it at a primary standard. Primary standard solutions in titrations are the solutions जो अपने आप में खुद ही change दिखाते हैं. So sodium dichromate doesn't show you change, and that's why it's known as a secondary standard solution. And the reason for that is sodium dichromate is hygroscopic in nature. Hygroscopic is that it absorbs the moisture. So because it absorbs the moisture, अगर आप उसका solution बनाएंगे तो वो अपने आप को पहले dissociate कर देगा, and probably it won't be able to show you any kind of change in the titration process. So for this, assertion is also true, reason is also true, and reason is the correct explanation of assertion as well. Second statement that we have is that the orange solution of dichromate turns yellow when pH of the solution is increased. Now, this statement is correct because dichromate apne aap mein naturally, when you make a solution of it, it is orange in color. And when you keep on, titrating it with somebody, you keep on increasing the pH, it goes from orange to yellow. So that is why this is correct. And the reason here it says that color of dichromate gets bleached. No, there is no bleaching thing happening here. It is just that when pH level is changing, so you all have seen that universal indicator thing, आपको pH chart पता है. So जब pH increase होना शुरू करेगा, तो of course हम लोग lower pH से higher pH पर आते हैं. यानी pH 1, 2, 3 to 7 हम आते हैं. तो अगर आप neutral water का pH देखेंगे, तो it's somewhere green in color. So orange to yellow and probably to green, and then ultimately we go to the higher colors. फिर वो blue हो जाता है, blue होके फिर वो purple color shade में चला जाता है. So that's how the color changes. So that is why there is no bleaching happening here. Assertion is definitely true, but reason is false here. Third, lanthanoid contraction is not more than the actinoid contraction. So it's definitely, actinoid contraction is more. Why is it more? उसका reason मैं आपको समझा देती हूँ. Because actinoid contraction में उनके पास जो size है ना, वो ज़्यादा हो जाता है. So actinoids have 5f orbitals. Lanthanoids have only 4f orbitals. So because of that, lanthanoid contraction is more. Reason is actinoids have 5f orbitals being filled, which are more dispersed in space compared to 4f orbitals. So that is correct. That is correct. वो मैंने अभी आपको explain किया है. तो उसकी वजह से because actinoids are more dispersed, the contraction also has to be more for actinoids in comparison to lanthanoids. So assertion here is false, but reason here is true. Fourth statement is mixed metal is a pyrophoric alloy. Now, when I say pyrophoric alloy, it means that it is, resistant, or it is being impacted with the heat. Pyro का word meaning यहाँ पर science में heat से related होता है. So mixed metal is prepared from lanthanoids. So assertion is also true, reason is also true, but it is not explaining because why is it heat based alloy and it is prepared from lanthanoids doesn't explain the concept. So assertion, reason both are true, but they are not explaining each other pretty well. Next statement that we have is actinoids show more variety in oxidation state than lanthanoids. So for this, we have the assertion to be true, but reason it says that actinoids have comparatively larger size than lanthanoids. So that is also true. It shows more variety because size बढ़ जाता है. मैंने अभी पिछले वाले सेशन में भी ये चीज एक्सप्लेन करी थी कि जब when we go down the group या when the atomic size is increasing, तो automatically nuclear force of interaction impact होती है. So oxidation states भी आपकी variety of oxidation states you are getting. So A and R both are true, but reason is not the correct explanation, and that is why we'll go with the B option. Sixth statement is zirconium and hafnium have similar properties. So this assertion is definitely true. Zirconium and hafnium lie in the same group of the periodic table. That is also true, and that is why they have similar properties. But both of them do not explain each other pretty well, and that is why we say that assertion and reason both are true, but reason is not explaining is not being explained properly. So that is why we go with the B option. Seventh statement that we have is highest oxidation states of D block elements are usually seen in oxides and oxoanions. So जब हम oxygen based compounds की बात करते हैं तो वहाँ पर हमें maximum oxidation state मिलती है. ये absolutely correct है. And why is it so? It says oxygen is capable of forming p pi d pi bonds with transition elements. That is also true because oxygen के पास है vacant p orbitals. ठीक है, और ट्रांजिशन मेटल्स के पास है वेकेंट डी ऑर्बिटल्स। सो ये डी ऑर्बिटल्स इस पी ऑर्बिटल्स के साथ फॉर्म करेंगे और बाई पी पाई बॉन्ड्स बनाएंगे। सो assertion also is here true, reason also is here true, and it is pretty explaining it well. That is why, क्योंकि ऑक्सीजन की वजह से ही तो बॉन्ड बन रहा है, that is why oxides and oxo anions are there. Eighth statement that we have is higher oxidation state and transition metals are more covalent than lower oxidation state. More covalent matlab they can be more shared. The number of electrons being shared are more than when you have higher oxidation states. And correct me here if I say that I have an oxidation state of +4. What does that mean? I have lost 4 electrons. The element has lost 4 electrons. So of course covalency आएगी, sharing हो रहा है या loss हो रहा है, so covalency आ रही है. Reason here is that higher oxidation state involves more d electrons. That is also true. So reason is also true, assertion is also true, and reason is explaining the assertion pretty well. So we go with the first option. Ninth statement that we have is manganate ion is paramagnetic while permanganate ion is diamagnetic. So paramagnetic and diamagnetic मैं आपको already बता चुकी हूँ. मैंगनेट आयन की जब हम बात करते हैं, परमैंगनेट की बात जब हम करते हैं, तो परमैंगनेट इज MnO4-. सो यहाँ पर आपको मैंगनीज की ऑक्सीडेशन स्टेट निकालनी है, जैसे हमने रिडॉक्स रिएक्शन क्लास 11 में किया था, और वहां से आपको ये निकालना है कि कितने नंबर ऑफ अनपेयर्ड इलेक्ट्रॉन्स है. जितने भी नंबर ऑफ अनपेयर्ड इलेक्ट्रॉन्स होंगे उसके बेसिस पर आप बता सकते हैं कि वो पैरामैग्नेटिक है क्या डायमैग्नेटिक है. सो हियर इफ यू एक्चुअली कैलकुलेट, मैग्नेट आपका पैरामैग्नेटिक होगा और पैरामैग्नेट आपका डायमैग्नेटिक होगा. असर्शन आपका ट्रू है. रीजन आपका यहाँ फॉल्स है. मैग्नेट आयंस हैज 2 अनपेयर्ड इलेक्ट्रॉन्स नहीं, उसके पास ज्यादा होते हैं, तो आप कंपैरिजन करेंगे तो आपको समझ आ जाएगा. Next assertion that we have is HCl cannot be used for acidification of permanganate titration. यानी जब भी आप परमैंगनेट बेस टाइट्रेशन करते हैं, पोटेशियम परमैंगनेट बेस टाइट्रेशन करते हैं, तो आप HCl को यूज नहीं करते. यस, बिकॉज HCl उसके साथ रिएक्ट नहीं कर पाता है एंड ऑक्सीडेशन प्रोसेस बढ़ जाता है, जबकि परमैंगनेट अपने आप को खुद ही ऑक्सीडाइज कर रहा है एंड HCl also is oxidizing, so ultimately the reaction is not balanced. Reason उसका है that HCl gets oxidized to chlorine in the presence of permanganate. That is what I wanted to explain. So assertion here is true, reason here is also true, and they are pretty explaining each other well. So that's all from my side for this session, and we will meet you for next session. And till then you can see all these videos. The links are here, the channel details are here, and that's all from my side. Thank you.